Hello dear fans. How to calculate the wavelength. The wavelength, the speed of its propagation and the frequency of oscillations are quantities related to each other. The most rapidly moving electromagnetic waves in a vacuum, the speed of their propagation in other media is noticeably slower. Sound waves are several orders of magnitude slower. Instructions. Step 1. Before starting the calculations, translate all the values presented in the problem statement into the SI system. Convert the speed of propagation of waves in meters per second, frequency in hertz, cyclic frequency in radians per second, wavelength in meters. The refractive index is dimensionless. Step 2. To calculate the wavelength, divide the speed of propagation by the frequency. If a cyclic frequency is given in the problem statement instead of the usual frequency, pre-calculate the usual one by dividing the initial value by 2 pi. Step 3. The speed of light in a vacuum is a physical constant of 299,792,458 meters per second. In any other environment, it is slightly less. The denser the medium, the more it slows down the propagation of electromagnetic oscillations in it. If any particle moves in a substance with a speed that, although lower than the speed of light in a vacuum, it simply cannot be otherwise, is higher than the speed of light in this very substance, the so-called Vavilov-Cherenkov glow appears. To find out the speed of light in a particular medium, find its refractive index in a reference book, and then divide the speed of light by it. Air is an exception to this rule. Its refractive index is so close to unity that it is usually neglected and the speed of light in it is considered equal to the same value for a vacuum. Nevertheless, under certain conditions, the Vavilov-Cherenkov glow can be observed in it. Therefore, if the task requires increased accuracy of calculations, take the refractive index of air equal to 1.0002926. For distilled water, this indicator is 1.33. Step 4. If the speed of light decreases with increasing density of the medium, then the speed of sound increases. This is due to the fact that matter prevents electromagnetic oscillations from spreading, and mechanical ones, on the contrary, cannot propagate without it. In a vacuum, the movement of sound waves is completely impossible. No coefficients are used to calculate the speed of sound in a particular environment, but the values of the speeds themselves are taken from the table. Take the speed of sound in air at 0 degrees Celsius and atmospheric pressure as 331 m/s, in distilled water at the surface as 1348 m/s. Thanks for watching.